Alright, in here, we're going to come up with the equation of a hyperbola, given some specific information. Alright, now, we have to remember that when we're given the vertices, we're given the a value. So we need a squared. So a is equal to 3 or negative 3. So if we square it, we're going to end up with 9. So a squared is equal to 9. Okay, now we're given c squared. We're given c, so what we need to do is count, but we need b. So we're going to have to use the formula b squared is equal to c squared minus a squared to come up with our to come up with our b squared. Okay, so we know that this is our c. C value is equal to 5. Therefore, if we square both of them, we end up with c squared is equal to 25. So what we'll do is place our c squared in and our a squared and see what b squared is. So we'll have 25 minus 9 is equal to b squared. Okay, so b squared is 16. So now we have a squared and we have b squared. Now we have to decide what our equation will look like. Now, since the vertices has an x value here for 3 and negative 3, that means x will come first. So it would be x squared minus y squared is equal to 1. Now what we'll do is put our a squared underneath the x. And again, we're coming up with that because of the vertices. Tells us which comes first. So put 9, and then we'll have 16 for our b squared. And so that is the equation of our hyperbola. Now, let's go ahead and check our answer, and then we'll go on to the next one. Okay, so we end up with 9, which is what we had. And if we double check over here, yeah, that's what we had. Alright, now we'll show you another example. Alright, now with this one, same type of problem. Well, but a here is equal to 12, so a squared is going to be equal to 144. Okay, now we got to come up with b squared, because in our equation we have to have both a squared and b squared to come up with the equation of that hyperbola. So now what we'll do is again use the fact that we know that b squared is equal to c squared minus a squared. Well, c is equal to 13. Therefore, when we square it, c is equal, c squared is equal to 169. So we'll have b squared is equal to 169 minus 144. Take the difference, and b squared is equal to 25. Okay, now we have all the information that we need. We just need to know where to plug it in. If you'll notice here that the 12 is in the y location, so what we'll have for this one is y squared minus x squared is equal to 1. Okay, we'll put the 144, which is our a value, and it always comes first. A always comes first. And then b, which is 25. And so that is the equation of our hyperbola. And again, we'll check our answer. And that's what we came up with. Y squared over 144 minus x squared over 25 is equal to 1. So that was the equation of our hyperbola, which is what we discovered here. Alright, let's look at another example. Alright, this one, similar numbers, okay, but we got to come up with a squared. So a is equal to 5. We're going to square it. A squared is equal to 25. Okay, now we know that we're given the c value as far as c is equal to 13. So c is equal to 13. Okay, and we'll square it. C squared is equal to 169. Okay, so I have a and I have b. I have a and I have c. I need to come up with b. So b squared is equal to 169 minus 25. Okay, so b squared in this case will be 144. Okay, and now we have to decide what comes first, x or y. We look over here, this is in the x location, so the vertices will be, It tells us which come first, x or the y. So it tells us x. Alright, so it would be x squared minus y squared over 1, equal to 1. So we put b squared underneath the y, and then a squared will go underneath x. So we end up with x squared over 25 is equal minus y squared over 144 is equal to 1. Okay, and so that's how we can come up with an equation of hyperbola given this information. But I guess we'll go ahead and check our answer. This is what we came up with, and